questions? That's just the synthetic. It was just the second page of synthetic was all you have to remember. 1 and 2. So 1 and 2 used factoring. They were a little bit different, and we'll be doing some more factoring today. So the first one, x squared plus 8x minus 84 over x minus 6. So I factored the top there, and this is a shortcut because it's a leading coefficient of 1. So what multiplies to negative 84 but adds to 8? 14 and 6. So x plus 14, x minus 6, and then I've got x minus 6 on the bottom. Those cancel, so when you divide those, you just get x plus 14. That's exactly right. You could have done synthetic on that, but it said to solve by factoring, but you'll still get the same thing. It's one of those things where you got different ways that you can do the same thing. And then number 2, same kind of problem, but it's not a shortcut factor. Minus 2. So what multiplies to negative 60a squared but adds to 11a squared? (15 and 4). I had to think about that one for a second. 15a and negative 4a. I'm going to write the negative first, as we usually do. Slash, what can you take out of the first two? 2a, and it leaves me with a what? No, that doesn't work. Oh, this is supposed to be 15. Sorry. Yeah. 3a minus 2. Take out the second 2. What's left? That's right. Over 3a minus 2. I hope you see what's fixing to happen. Yep. You got the 3a minus 2 times 2. Oh, I'm writing too fast for it. 2a plus 5 over 3a minus 2, which cancels and leaves me with, of course, just the 2a plus 5. What else on your homework as far as synthetic division there? 7. It's important that you can do synthetic division very easily, especially with what we're doing today. W to the third minus 2w squared minus 2w plus 1 divided by w minus 1. Do I need any placeholders? No. So I'm going to set up, remember it's opposite sign outside, and then inside are my coefficients. 1, negative 2, negative 2, and 1. Drop it, multiply and add, multiply and add, multiply. Did I go too fast? Drop, multiply and add, multiply and add, multiply and add. This is my remainder, constant, x, and x squared. So this equals x squared minus x minus 3. Oh, you're right. Thank you. W squared minus w minus 3. And then you can either do plus negative 2 over w minus 1 or minus 2 over w minus 1. Either one's fine. Always start at the far right. No, remainder constant and go up from there. Yes. That's exactly right. Yep. Yes. Ooh, number 10 needs a placeholder. 2x to the third. I'm missing the x squared, so I'll put 0x squared here. Oh, that's okay. All right, p to the fourth. I don't have a p to the third, so I'm going to do a 0. Minus 7p squared minus 32p minus 15 divided by p minus 4. It's a lot of p's. 4 goes on the outside. What are the numbers inside? 1. Exactly right. Drop down the first one, and then let's start to multiply and add. So multiply and add. I feel like I'm doing like an 80s aerobics thing. And multiply. And add. And multiply. And add. And multiply. And add. Okay? Remember, that is 3/4 of the problem, but you're not done until you interpret your answer. And so this is the remainder, the constant, the x, the p squared, the p. So this equals p to the third plus 4p squared plus 9p plus 4 plus 1 over p minus 4. Yes. That's fine. That's fine. Anything else here? 11? Okay. You're talking about the very first one? The very first one just drops down. You're always multiplying by the number outside. So you multiply and you write it here, and then you add that column. And then you take this number out here and you multiply that again and add. And then you take this number and multiply it. It goes there and you add. You're always multiplying by the number outside. Jaquarius, you said 11? X to the fourth minus 2x cubed minus 29x squared minus 43x plus 8 divided by x minus 7. Change the sign, so 7 on the outside. I've got 432x constant. I am good there. 1, negative 2, negative 29, negative 43, gross, and 8. 1, 7, 5. What's negative 29 and 35? 6. 7 times 6 is 42. Negative 43 and 42 is negative 1. Multiply and add. Remainder constant, x squared, x cubed. So this equals x to the third plus 5x squared plus 6x minus 1 plus 1 over x minus 7. Very good? All right, let's switch gears. I'm going to apologize before we start. Did you get talked to him? Wasn't that something? Apparently you just got to track him down. All right, if this doesn't look as pretty as your other ones, I'm sorry. My fault. I typed it up real quick yesterday and finished it up this morning. We're going to talk about 3 big things today: factor theorem, remainder theorem, and then rational zero theorem. So 3 big theorems today. This is where it all comes together. I can give you one rational zero problem, and you have to do everything you've learned so far in that problem in order to do it. So that's where we pull it all together. So I'm going to lead you to that point, okay, with what we got. So the first thing, let's review some synthetic division there. And there's a reason that I have those there, I think. Let's do number 2. No. Number 1 is synthetic. Yes, let's go to number 2 because we just did a bunch of synthetic division. You can do number 1 on your own there. I give you an equation, and I said evaluate f of 1. Now, first of all, what does that mean? If I say what's f of 1? Plug it in. I'm plugging in 1 for every x. So do that real quick and tell me what you get. What do you mean the same thing? It just goes, yeah, it just goes in for the x's. Did I mess up on the very first one? It's supposed to be -1. No, it's not. What did I do? Oh, y'all. Just on that. I worked so hard on this packet yesterday. God, and I messed up on the first one. Hold on. Remember what I was trying to get you to see now. All right, so keep going. What do you get here? No, it's 1. It's just 1. I was right. 1 plus 3 plus 4 minus 1 is what? 7. Now I want you to go back up to number 1 that I told you to skip. Don't skip it now. Let's go back to it. I told you to take this same equation, expression, polynomial, and divide it by x minus 1 and do it synthetically. So do that on your paper real quick and see what happens. What's the quotient? Right? Gosh, Stacy, what is wrong with me today? I need to start over. Okay. I might have to re-record this lesson in third block because I have just royally messed it up. I did that on purpose. Nobody noticed there wasn't a placeholder there. Shame on y'all. I know. I'm picking. I messed up. That was on me. Okay. 1, 1, 1, 1, 1, 1, 4, 4, 8, 8, 7. I apologize. Okay. -1 plus 8 is 7. Which means this is x cubed plus x squared plus 4x plus 8 plus 7 over x minus 1. Now are we all on the same page? Okay, now what is the quotient here? The answer. What is the remainder? 7. What do you notice about numbers 1 and 2? They both gave me 7. The remainder was 7. Notice what I plugged in here. I plugged in this value, right? But what I divided by was actually x minus 1, right? So when I plugged in the opposite sign, I got the same thing as a remainder there. So that's going to be what our remainder theorem is. So if you look down, I typed in the definition of a remainder theorem. If you don't quite understand yet, it's okay because I flubbed that way up. Hopefully, I'm going to clear it up. When you divide a polynomial by a linear factor of x minus a, okay? So if I could synthetically divide it, same kind of thing, right? Then the remainder, if you divide by x minus a, then the remainder is what you get when you plug a in. Now notice I've got to change the sign here whenever I plug in. So look at number 3. I told you to find f of 5, but use synthetic division to find f of 5. So let's think about this for just a minute. If I've got f of x equals negative x cubed plus 3x squared minus 5, right? If I want to find f of 5, and I don't want to just plug it in, I want to use synthetic division. F of 5 is going to be the remainder when I divide by x minus 5. Does that make sense? The answer, what you got when you divided it. Let me show you why this works. I'm going to show this to you both ways. So let's put the 5 outside the synthetic division. 3, 2, I'm missing a 1, right? I need a 0x. What do you get? Everybody get that? Is that what y'all got? To do my math right? Now remember, this is all I was given, and this. But I'm telling you that this means if I divide by x minus whatever this number is, then this should give me my remainder, right? That f of 5 should be negative 55. Does that make sense? So when I divide by x minus a number, if I just plug that number in, I get the remainder if I were to divide. Let's see if it works. If I do this algebraically, negative 5 cubed plus 3 times 5 squared minus 5. What's 5 to the third? Y'all should know that one. Negative 125. 25 is 5 squared times 3 is 75. They're all coming back to the same thing. That's what I'm trying to get you to see. The remainder and that value are both the same. Look at number 4. Well, let's do number 5. Let's do number 4. Let's do number 4. Yep. So for number 3, you don't write the quotient. I just want you to write the remainder and f of 5, which should be the same thing. That's what I'm trying to get you to see here, is that they're the same value. You don't understand? No, that's what I plugged in. Y'all are not understanding what I'm saying. Let me try to explain it a different way. I know. Let me try to explain it a different way. If I take any polynomial and I divide it by x minus a, okay, that's that synthetic situation. The remainder I get is always what you would get if you plug a into the equation for x. That's going to be your remainder every single time. So if you had like number 6, f of x, we'll come back to it in just a second. I think this one will be a little easier for you. 2x to the 4th plus x cubed minus 3x squared plus 2x. If I divide that by x minus 2, okay? Now, before I actually divide it, okay, if I were to synthetically divide this, I could easily find the remainder. Do you agree? But what I also know is that the remainder, when I divide, is going to be f of 2. Always. Always. Yep. Okay. Yep. So let's check it and see. The first thing, let's do f of 2. So plug 2 in for every one of these x's and see what you get. What'd you get? Everybody got 32? Okay. Now come off to the side and do synthetic division. So 2 on the outside. I need a 0 for the constant place there because I don't have a constant. What do you notice? It's exactly the same. So what I could do instead of dividing is I could just plug in and find the remainder. Does that make sense to you now? Do you see what I was trying to get to there? A little bit? Okay. We're going to do more of these as we go through this. I don't think we're going to get to the PRZs today. I think we might save that for tomorrow, which would mean your test would be on. Okay, factor theorem. I will try my best to have your whole review packet ready for tomorrow, though, so if you're not here on Monday, you have it. All right, factor theorem. Knowing that the remainder is 0 is very useful. What? When you divide a polynomial by x minus a and you get a remainder of 0, what do we call x minus a? We talked about this briefly yesterday. A factor. That's exactly right. We call it a factor. In fact, if you divide anything, let's take 6 divided by 3, and I get no remainder, that means that this is a factor of 6, right? Not only is that a factor, or actually we say both of these are factors, but this is a factor also. So both of those are factors. When you divide, you get a remainder of 6. Both of those are factors. And if I wanted to write 6 in factored form, I would take the two factors and multiply them together. Does that make sense? I take what I divided by, that's your x minus a, and I multiply it by the quotient, and that gives me what I started with. That's the thought process that we're going to use here. It lets us find all the roots and factor it completely. So I've got 3 things there. There are three ways to determine if x minus a is a factor of the polynomial. Tell me one way you could tell if it's a factor. But how can you tell that? If it goes into it, how can you tell? How can you tell? Synthetic division. One would be synthetic division with a remainder of 0. What's another way you could tell? Long division with a remainder of 0. There's one more way. Plugging it in like we just did. If we plug in the value and we get 0, we know it's a factor. Okay, so those are the 3 ways. Synthetic division, remainder 0. Long division, remainder 0. Or plugging it in and getting 0. Yep. Long division, remainder 0. Synthetic division, remainder 0. Or you plug the value in and you get 0. All right, let's look at number 7. Here's where we get to the good stuff. I know. I'm glad you're so excited, Hannah. Can hardly contain yourself, can you? I've got a function. And then it says that one of the factors is x plus 5. One of the factors. So that means x plus 5 times something gives me that, right? How do I find this? I divide it, right? We already said if you divide by one factor, you get the other factor, okay? So the first thing I'm going to do, and if you want to write this in that little column on the left, if I'm factoring given a factor, the first thing that I do is divide by the factor. Right, because that's given. They give me one factor. Because if I just looked at this, I'd have no idea how to factor it, right? Okay, so what is x to the third plus 6? And all of these will be synthetic. That's why I told you synthetic was so important. They'll all be able to be done synthetically. All right, plus 6x squared minus x minus 30 divided by x plus 5. Divide that out and tell me what you get. Synthetic, yep. What happens if you get a remainder here? You did it wrong. That's exactly right. You did it wrong. Because if it's a factor and you get a remainder, you did something wrong. Because the definition of a factor is you divide it and you get no remainder. So when I divide these two, I get x squared plus x minus 6. Do we all agree? Okay. Now I'm going to write the two factors because I have two factors now, right? This was a factor, and what I got when I divided was a factor. I'm going to write the two factors as a multiplication problem. That's this one and this one. So x plus 5 times x squared plus x minus 6 is the same thing as this. Do you agree? If I divided 6 by 3 and got 2, then I could say 2 times 3 is equal to 6, right? I did the same thing. Now remember, what were my directions for this problem to begin with? Factor it completely. Okay. I can finish factoring from here. X plus 5 is already factored, right? I can't do anything else with that. But how about this? That's exactly right. It's a shortcut. You can break it up into 3 and negative 2. Is it now factored completely? Yes. That is factored form. Okay, so that's your first blank, factored form. Now it asked me to do something else down there. What did it say? Find the zeros. How do you find the zeros? You put each one to 0. Set it equal to 0. So what are the zeros here? What does that mean on a graph? That's where it's crossing the x-axis. That's exactly right. X-intercepts. What do you think? That's one of the three big things, is factor completely given a factor. Let's do one more. Pick one, anywhere between here and 11. 11? Flip over to 11. Factor completely given that factor. The first thing I want to do is what? Divide them. That's exactly right. So what I'm really going to do is this. Synthetic, and again, these will all be synthetic, so it should not take you forever. 3 on the outside. Don't forget to check for placeholders. 3, 2, 1 constant. I'm good. And when I do this, I better get a remainder of, good job, 1, 3, negative 3, negative 9. And you're on it today. I know. Did you get your nap in first block instead today? What? All right, so when I divide these, I get x squared minus 3x plus 2. Now write it as a multiplication problem. In other words, put the two factors together. I've got x minus 3. I'll factor it in just a second. Now I lied. Now factor it. It's a shortcut. We like the shortcut ones, right? X minus 3. What multiplies to 2 but adds to negative 3? Negative 2, negative 1. There's my factored form. How about my zeros? Once you get to this point, it's pretty easy. You don't even have to write them out to solve them. It's pretty easy to see. Are we all good there? Let's do it backwards then. Not really backwards, but let's start with a 0 and find the other zeros. Okay? All right, first thing, remember when you plug in a 0, not when you plug in 0, but when you plug in a 0 or when you plug in a root, what should you get if you plug that in? You're right. Somebody was saying it. 0. When you plug in a value, if I plug in 1, right, f of 1, that should tell me the remainder when I divide by x minus 1. And what should the remainder be? 0, because it's a factor, right? So when you plug in a 0, you should get 0. That's your blank. Okay? That tells me that x minus a is a factor. And then I have some steps there. How do you find all the zeros given 1 0? Okay? We're going to first, and I think I'll do this while I work through that example on number 12. We have f of x equals x to the third minus 8x squared plus 4x plus 48. And it says that x equals 4 is a 0. Okay? Well, if x equals 4 is a 0, tell me what you know is a factor. X minus 4. Because x minus a 0 is always a factor. Well, if you know this, I can find all the rest of them. Okay? So I'm going to use this. I didn't even write on here that that was the factor theorem. Okay, that's the factor theorem. I'm going to put that on. I guess I put it up at the top of the other one. Okay. Now all I have to do is do everything that I did before, right? So now I'm just going to factor by dividing and find the zeros. So I'm going to divide this by x minus 4, and I better get a remainder of 0. That's the key here. So I'm going to put a 4 outside. 1, negative 8, 4, and 48. 4, negative 4, negative 16, negative 12, negative 48. So I factored by dividing. I should actually say, oh, I've already got steps for you over there. So factored, this looks like x minus 4, x squared minus 4x minus 12. Agree or disagree? Finish factoring. Remember whenever I told you at the very beginning factoring was the foundation of this class? Do you believe me now? Factoring quadratics is crucial. Okay, I can shortcut this because there's a 1 in front, right? All right, so I've got x minus 4 in the lead. What multiplies to negative 12 but adds to negative 4? There you go. 6 and 2. But this problem did not even ask me to factor it completely. It asked me to find all the zeros given that 1 0. So what are all the zeros of this problem? 4, 6, and 2. Do you think you can do this? Okay. For tonight, I would like for you to go through 15. That doesn't give you a whole lot to do on your own, but it gives you some. We will do the rational zero theorem tomorrow, unfortunately.